All right, for this bell work, we're looking at equation just like we saw last time. It's a two-step equation, meaning we're going to need two principles of equality to solve this. And when we solve principles with principles of equality, first thing we should do is try to make a zero if we can, keeping in mind that in the future we're going to see some distribution and combining like terms, but we're not seeing that yet. And so we don't want anything added or subtracted to whatever x's we have. This one's 2x's. But we definitely don't want anything added to it, like the plus 3. So we're going to make the 3 a 0 by subtracting 3. Because 3 minus 3 actually is 0. And even if you were to bring down this 2x right here, you'd have 2x plus 0. But with this principle of equality, we really want that to be a phantom 0. So I'm going to make it a phantom 0. Still there, you just can't see it. And this line will bring down the equal sign. So I subtracted 3 on the left side of the equal sign. Principles of equality say if you do it on one side, you got to do it the other side. So I got 19 minus 3 as well, which is 16. So now I got this new equation, 2x equals 16. And whatever value of x I get from this should not just make this equation true, but the original as well. Now the problem here is we got 2x's. There is the plus 0, but we don't want 2x's. In the end, to solve this, we just want 1x's. Okay, 1x to equal something. Not 2x's. So how do I make a 2 a 1? This goes back to what we saw last time. So we just used a minus principle of equality to make a 0. To make 1s, we use either multiplication or division. So the 2 there, I'm going to make it a 1 by dividing it by 2, okay? So that's going to give us a 1 there. And then the 16 also, I'm going to divide it by 2 to get 8. Now this should be the solution. But before I continue here with this 2x equals 16 stuff, okay? So some of you, when you see this 2x equals 16, there's still some of you guys that are coming in and being like, hey, don't I subtract 2 from both sides? And there's two problems with this, okay? So 2 minus 2 is 0. So even if you could combine these, you'd have 0 x's. But you can't actually combine these anyways because 2x and a minus 2 term, these are not like terms that you can combine. And when we talk about combining like terms, that is with the operations of addition and subtraction. You can't subtract these two, okay? So this strategy together is completely wrong because not only can you not combine like terms, but then if you did this wrong anyways, you'd get a coefficient of 0. But we want the coefficient to be 1, okay? That's why we divided by 2. Last thing we're going to do on this is just check. Okay, so we're going to go back to the original equation, 2x plus 3 is going to equal 19, right? Right now, we're pretty sure if we replace x there with 8, we should get a true statement. So I'm going to check for truthfulness on this. There's my question mark. 2 times 8 is 16. Then I add the 3, which equals 19. It should equal 19 anyways, but 16 plus 3, yeah, that does equal 19. So 19 does equal 19, that's true. And since we found that this was a true statement, now I can box this in. So I think I'm going to start keeping the 1 coefficient right there because I think a lot of you are still misunderstanding what it is we're trying to get as the coefficient of 1. Either that or you're just being so robotic you're not thinking about what the crap you're doing, okay? We're trying to get a 1 as the coefficient of x. And yeah, that may take some thought right now until you get a little bit more experience with this about what you have to do to make that coefficient of x a 1. There's our objective for the day then. And I know how to make sure my answers actually are solutions to equations. That's exactly what we did on the last part of that bell work problem, okay? So all you're going to do is replace whatever value you find for x or whatever the variable is. Replace that in the equation with the number, and then you check for truthfulness. That is all. Take 30 seconds to copy this down, please. All right, going back to what we've seen, this is just more review. Remember that equations have equal signs somewhere in the math sentence. Expressions do not. So another way to say this is equations is a comparison of two expressions. Sometimes the expressions have x's, sometimes they don't. Just depends on what we're looking at, okay? But there has to be an equal sign somewhere in the sentence in order for it to be considered an equation. If it doesn't, it's automatically an expression. then what is the solution? And this is kind of going back to, we've seen this quite often, but now it's a specific objective for us today. A solution to an equation is a value of x, we're going to say, to make the equation a true statement. Because remember, it's possible, if you look at an equation, something like, I don't know, 10 equals x plus 7, something like this, right? You could say that x equals 3, and if you did, this x equals 3 would be the solution to this equation. Well, what does this tell us about non-solutions? It means that every other value that you could try to replace x with would make the equation a false statement, okay? Now we can keep the equal sign in there, it just becomes a false statement. That's the important part. Don't be deceived that this looks like it's false from the beginning. Once you check to make sure, which is our objective, you may find some values to be false. If they are false, then you're going to need to go back and see where perhaps you made a mistake in either calculation or maybe used the wrong principle of equality, or even you just typed it into the calculator wrong. You got to find out. So this whole idea, the whole objective today is so that you understand that independently you can do this on your own. You don't need Mr. Sal, you don't need some kind of expert saying, your answer is correct. You can do this on your own and figure it out for yourself. As long as you will do the checking. Okay, and I've already told you guys this. If you come back and ask, hey, Mr. Sal, is this correct? I'm going to ask you if it is. Because you can find out on your own if it actually is correct or not. Okay? So that's what you're going to be doing. That's the whole objective for today, is to make sure that the values you find are actual solutions. So here's our principles of equality. Remember, principle of equality, just to summarize this, is it's really just asking you whatever you do to one side of the equation, well, equal sign, you must do to the other side of the equal sign, okay? And when we're talking about doing things to one side or the other, that is with these 4 operations: addition, subtraction, multiplication, and division. But there are also specific objectives when we look at, well, to start with addition and subtraction, okay? So let's look at these two. If you're looking to add to both sides or subtract to both sides, the objective for you is to make some kind of zero, okay? And eventually when we get those zeros, we make that a phantom zero. They will become phantom zeros. Now, not only that, but just like we saw in the bell work, we make zeros first. For now, anyways, okay? Eventually, maybe we may see some distribution, some combining like terms, in which case this would not be first. But for now, it's first. When we're looking at two-step equations, okay? Then, after you've done that, then you're going to look at the coefficient of whatever the variable is, usually x, okay? And that's where these two come in, multiplication or division principles of equality. We use these to make the coefficient which we've seen already, coefficients, a 1, okay? And like I showed on the bell work, I'll start keeping the ones just so we understand what that coefficient actually is. Because after having erased it in the past to make it a phantom 1, some of you are mistaking that for a phantom 0, but it's not, it's a phantom 1. And like it says here at the bottom, we should only need 2 of these principles of equality. Again, first, you're going to make zeros, and then second, you'll be looking to make coefficients 1s. But you have to use one of these 2 principles of equality to do that, multiplication or division. So all this is review, which then leads us to the first one we're going to see. Is 19 the solution for the equation 135 equals 7x plus 2, okay? So what this is saying is 19 the solution, right? So it's really asking if you replace x with 19 in the equation, will you get a true statement? Now the statement again is at the equal sign, okay? So I'm going to go in here. Okay, this is saying that x should be 19, but we're not sure if it is or not. So I'm going to go into the equation and do that, okay? So I'm replacing x here with 19. And the rest of the equation is not affected. We got the 135, it's going to equal the 7. That's multiplied by 19, just in case you were wondering. And then we got to add 2 to that. Now, I'm not sure if this is true or not, so I'm going to put a question mark over the equal sign. Then I'm going to use the order of operations to figure out if this is true or not. Of course, you could just plug it in the calculator, but it's not too bad. 7 times 19, I guess I will use a calculator for that. 7 times 19, I got 133. So we still got the plus 2 there. Does this equal 135? Well, if you add 133 and 2 here, you get 135. Which, compared to 135, that's a true statement right there. So now that we know that this is true, we're going to say, yeah, this is the solution there. Keep in mind, though, on the assignment, it's just going to ask for true or false. Is 19 the solution for the equation? I guess on the assignment, you just write true, but I like yes, it just sounds better to me. Then on this one, is 14 the solution to this equation? Let's find out. So again, we're saying x equals 14. That's a question, by the way. There's my question mark over the 14. I don't know if it is. Let's go into the equation and figure this out, okay? So I'm going to replace the x here with 14. So that would be 14 over 7. And remember, the fraction line there is a division sign, really. So we got negative 9 equals negative 7 plus now 14 over 7. But I don't know if this is true or not, so I'm going to put a question mark over the equal sign. And I'm going to check. So by the order of operations, I would have to do this division. First, 14 divided by 7 is 2. Now the equation shows negative 9 equals negative 7 plus 2. And I would combine now the negative 7 and 2 there. Negative 7 plus 2. A common mistake here is for students just to see 7 plus 2, which is 9, and then maybe attach the negative on here to say, hey, this is negative 9. It's not negative 9, you guys. And in fact, you can use the calculator to check. This is going to give you negative 5 instead. And as far as I know, negative 5 does not actually equal negative 9. This right here is a false statement. So again, on the assignment, you just click on false and you'd be good. Now, that means that x equals 14. It made this equation false, right? There's an infinite number of values that would make this false. Only one would make it true, but I guess that'd be negative 14, but you could figure that out on your own just by solving this with principles of equality too. So all this checking right here for falseness or truthfulness, that's stuff that you do at the very end of the problem after you've figured out what you think the solution is. So a 6 is the solution for this equation. You guys try this one. Try this one out. Take a minute, and we'll go over, okay? Now, if you're still working on this, do finish up. But I'm going to get started here. You can check your answers with what we get. So again, this is kind of like when you get to the end of the problem and you see that you got x equals 6. And remember, this is the same as 6 equals x, like this. It's the same thing, okay? But I'm going to go with the top one there. X equals 6. So we don't know if this is true if we make x equals 6. So I got a question mark over my equal sign there. And I'm going to replace this x in the equation with 6. Okay, so you got 6 over 3 minus 4. This should equal negative 6, but I'm not sure if it does. Okay, so let's find out. So by the order of operations there, you do 6 divided by 3, which is 2 now. So now we got negative 6 equals 2 minus 4. And I would now then take 2 minus 4, which is negative 2, okay? And again, if you're not very good with adding and subtracting or multiplying or dividing, especially with negatives, use the calculator, please, because it will know. It knows, and it knows for you. It wants to know for you if you'll just let it. This right here is false. Negative 6 does not equal negative 2. That's a false statement right there, which means that x equals negative 6. Is that the solution? No, it's not. Is 15 the solution to this equation? Well, let's find out. Again, I just want to emphasize this. This is stuff that you do at the end of the problem. So you would have already figured out that x equals 15 on this one. Right now, it's given us the 15, so I don't know if this is true. You could say, look, I'm going to use principles of equality to solve this, but we're just checking to see if this is going to be true, okay? So that means I'm going to, I guess it's A in this one, not X. Sorry about that mistake. So I'm going to replace the a here with 15. Let's see if this is true. Okay, so I got 15 over 15 plus 7. This needs to equal 8, but will it equal 8? That's the question. 15 divided by 15, that's a 1. 1 plus 7, will this equal 8? I think some of you can do that in your head, but I'm still going to show it with work because it's nice and thorough. 8 equals 8? Yeah, that's a true statement right there. So is 15 the solution? Yes, it is. And I like yes better than true, but whatever. That's pretty much the objective. As long as you can check your answers and do it accurately, then you're in good shape. So on this one, we got an equation now. Negative 2 equals 2 plus x over 6. It's a two-step equation, just like we saw on the bell work. So remember, the first thing I want to do is I don't want anything added or subtracted to my x's. I'm looking specifically at this 2 right here, okay? It's being added to this x over 6. And this isn't the addition, it's a plus 2 because it's positive, okay? That means I don't want it there, so how do I get rid of it? I just make it a 0. So I'm going to subtract 2. But if I do it to one side, I got to do it the other side, okay? So this line brings the equal sign down. And then on the left, I got negative 2 minus 2, which is negative 4. On the right side, I got 2 minus 2, which is 0, just like we planned. So again, there is a 0 there. And then this plus 6, x over 6, I just dropped that there, okay? I didn't combine anything with the x over 6. All I did is I got rid of this 2, okay? And that 0, I'm going to get rid of it too, okay? Now, some of you guys were struggling with equations that look like this on 5.2. If it looks something like this, okay? Negative 4 equals x over 6. Some of you guys were like, I don't understand what the crap is going on. Or, worse yet, you'd be like, I'm going to divide both sides by 6 here, okay? Now, it's a noble effort, though, to say I'm going to divide by 6. The problem here is that you're already dividing by 6, and some students are still like, I don't see the division sign. It's right here. It's the fraction line, okay? That's why you can't just divide by 6. Because it's like, divide by 6, divide by 6. No, that's not going to give us a 1. What we're going to do on this to make that divide by 6 a 1 is to multiply this side by 6. But if you do it to one side, you got to do the other side, okay? How does that become 1? It's because it's really 6 divided by 6 right there. Now, crossing this out, some people mistakenly say this cancels out. It's a 1. It's just it's slanted. It's a slanted 1. So I get 1x. And now this equals, well, 6 times negative 4 is 24. Okay, now I'm going to leave it like this with the 1x. You can make it a phantom one if you'd like, but I'm going to keep it like this, okay? So this is what we're looking at now. Negative 24 equals 1x. But is this true? Let's check. Because checking, I really hope you guys see that checking is not too hard. It's just, you gotta be able to do it, okay? And while math, sometimes we hate math, it really isn't that much extra work. So this is my equation, and I'm going to replace the x here with negative 24. And I'm going to check for truthfulness right there, okay? So there's a question mark for me. So by the order of operations here, I would have to do the division first. Negative 24 divided by 6, which is negative 4. So now my equation reads negative 2 equals 2 plus negative 4. Some of you would probably even change that to minus, but I'm going to keep the negative because the calculator will do this for me, just in case you're confused on that. So 2 plus negative 4 is negative 2, which does actually equal negative 2. That's a true statement. And since it is true, now I can go back to my solution. Negative 24 equals 1x. And I know now that this is the solution. Boom. Okay, so I'm keeping the 1 there just so you can understand. And again, there's been some confusion on what that coefficient needs to be. It's a 1. It's 1. Keep it as a 1, and that's fine. Now, you guys try this one out too. Negative 5 equals negative 5 plus 2/3 x. Take 1 minute, try this out, and then we'll go over it. So on this one, again, there's that negative 5 right here with the 2/3 x. I don't want that there. So I'm going to zero it out, all right? So to zero it out, it's a negative 5, so to make it a 0, I'm going to have to add 5. Just if I do it to one side, I got to do that to the other side. Okay, so this is going to bring down the equal sign. And yeah, negative 5 plus 5, that's going to zero out, just as we planned. And again, you could show this 0 plus this 2/3 x, which we are going to drop. Okay, drop down here. The problem now is on the left, I got negative 5 plus 5. Now, some students mistakenly just leave this blank right here. It's like, there's a phantom 0. No, we need something to be on the left side of the equal sign in order for this to have something to compare with the equal sign, okay? So that negative 5 plus 5 right there, I'm going to have to show that 0. I have to show it. But this plus 0 business, I don't need to show that garbage, so I'm going to get rid of it, okay? It's gone. Now, some of you are still struggling with equations that just look like this as well, okay? So if we take this away and you said 0 equals 2/3 x, some of you are still struggling with this, but whether the coefficient here is a fraction or whether it's a regular number, it doesn't matter, okay? We're going to go back here. And remember, the objective at this point is to make the coefficient of x a 1, not 2/3. So how do you make a 2/3 a 1? Just like anything else, whether it's negative, positive, whole number, integer, decimal, fraction. To make a coefficient of 1, you're going to divide it by itself. That's divided by 2/3, okay? So I got the 0 divided by 2/3 as well. And order does matter when you plug this into the calculator, okay? 0 divided by 2/3 is different than 2/3 divided by 0. So notice that, well, I took 2/3 and divided it by 2/3. The 0 I would have to divide by 2/3 as well, which when I put into the calculator, 0 divided by 2/3, I get 0. And yeah, again, the 2/3 divided by 2/3, that's a 1 right there. It's just slanted. There's the 1, 1x. 1x, 1x. Now, if we've done this correct, we should have the solution, but let's just double check, okay? So negative 5 needs to equal negative 5 plus 2/3 x, okay? Right here, I'm going to take my x and I'm going to replace it with 0, because that's the value I think x should be to make it a solution. Should be the solution to the equation, okay? And yep, here's my question mark for the equal sign too. So, just by the order of operations, I got 2/3 times 0, which is 0. So now I got negative 5 equals negative 5, but it's a plus or minus 0. It's not going to matter. And negative 5 plus 0, right there is a negative 5, right there. That's negative 5. Negative 5 does equal negative 5, okay, for now. So that's true. And since it is true, I can box this in. Okay, 0 equals 1x. You can make that a phantom 1 if you like. But as of right now, this is the solution. And again, this is the only solution that exists for this equation. There are infinite number of values you could use as x, but they would give you false statements, okay? So this is the unique thing about these equations and these solutions. Equations are true. They're true. They were true yesterday. They were true 100 years ago. They're true today. They're going to be true 1,000 years from now, okay? They're always going to be true when they are solutions, which means that there's an infinite number of values that are false, and those are the values you got to be careful about, okay? I know how to make sure my answers are actually solutions to the equations, which is, that's kind of the first 4 problems, but even when we're just doing regular equations like we did in the last 2 there, you should always be checking to make sure they're true, because you don't need anyone to tell you whether something's true or not. You can find out for yourself. And yeah, I'm talking about more than just equations, okay?